So one of the projects that I was playing with over the holidays was how to actually get ONNX Runtime working on a Raspberry Pi, which is actually pretty easy, which you'll see. So I did a computer vision model, and it's available in our docs as well. As you can see here, I also have the project in this video camera here. And let's go over some of the prerequisites first, right? So I'm using a Raspberry Pi 3, which there is newer and more powerful ones, but this is the one I have. I've already imaged it. So I've used the Raspberry Pi Imager. So if you haven't set up a Raspberry Pi before, they have made it so easy now. They have this like imager that you just download, and it's in a pretty graphics display. You put your SD card in to your computer using one of these, and then you just image it and you're good to go. And then you just add it in to your board here. So I've already done all of that. So we're going to be using the VNC viewer. So this is a nice little app that allows you to connect to your device. So that's what I have here. There is some configuration to do in order to get VNC viewer to work. I've already done that, and this is also linked in the blog, but you want to install, and then you want to do a config and make sure that you have it set up for you. Once you have it all set up and imaged, then you can boot your device and we can look at the code. So the source code, let me close some of these here. I have on my GitHub. One thing to think about is, the size of the model and how much computing power you need. So not all models are going to work. So we're using a model that is optimized specifically for this from the ONNX Model Zoo. Okay, so the ONNX Model Zoo, we have all kinds of different models here, and we are using a MobileNet model because they are small. They have pretty good accuracy, which means they can run on my device without issue. And I have already cloned this repo, so we'll go in it. But if you were starting new, you would want to go ahead and you can clone it directly to your Raspberry Pi from the GitHub, and it'll have everything for you. It has the model and the source and everything. So you would be good to go. So the code for the MobileNet, it's, like if you've done computer vision, this isn't anything that different. You have to preprocess it, resize it, all of those same things that happen with any computer vision model. We're using ONNX Runtime here, and then we're grabbing our model, creating our session. We're capturing an image and then writing it out. So we'll be able to see the image that was used. So when we run this, it's just going to print out the predicted classes, the top 5, and then it's going to show the image that it used. So the other thing that I added to this was a camera test, because like the first thing before I started running the inference to see if it was working, I wanted to make sure my camera was working correctly, right? Because I actually hadn't used this. I had got it, but I never actually used this camera before. So to do that, we use OpenCV in Python. I do a video capture, and then I also open a live video feed that you can hit escape to quit. So let's go to our, okay, so this is my VNC into my Raspberry Pi. And I've already downloaded this source onto my device. And so then to run the camera test, let's do the camera test first. We are just going to go ahead and hit run camera test, and then we should see a actual live video feed show up here in a minute. There it is. All right, so our camera is working. We'll escape out of that. And then we can also go to the thing here, and then we can look at our test snap that we did. There it is. We are now ready to run inference. So we will send in our script. It's going to snap an image, and then it will print out the results. And there it is. Fountain pen is correct. And here is the image that it used to inference. So that's all happening on device, which is pretty cool. If you make any Raspberry Pi projects with ONNX Runtime or any AI models, like let me know. I'd love to see them. And yeah, thanks so much. See you next time.